What if I told you that one of the most profound discoveries in physics came from a simple thought experiment? Yes, we're talking about the genius that was Albert Einstein, a man whose name has become synonymous with brilliance. Einstein wasn't always the revered physicist we know him as today. Born in the late 19th century, he was a curious child, always asking questions and seeking answers. One thing that fascinated young Einstein was light. He found it intriguing, mystifying, and it sparked a curiosity in him that would shape his future. Years later, Einstein was working in the Swiss patent office, a far cry from the glitzy world of academia. But it was here, amidst the mundane humdrum of patent applications, that he would make his groundbreaking discovery. He began to ponder, to question, to hypothesize. This is where we introduce the concept of a thought experiment. Einstein didn't need a fancy lab or expensive equipment. All he needed was his mind, his curiosity, and an unquenchable thirst to understand the universe. He began to ask himself questions. What if you could ride alongside a beam of light? What would you see? These questions, seemingly simple yet profoundly complex, were the starting point of his journey towards the discovery of the formula E=mc². Indeed, Einstein's genius was not in his ability to solve complex equations, but in his ability to ask thought-provoking questions. So, what was this thought experiment that led Einstein to the famous equation E=mc²? Well, imagine yourself in Einstein's shoes. Picture this. You're sitting comfortably in your patent office clerk's chair, daydreaming about riding alongside a beam of light. Crazy, right? But that's exactly what Einstein did. He pondered on what the world would look like if he could travel at the speed of light. Would the light beam appear stationary to him? This simple yet profound question sparked a revolution in his thinking. Einstein's thought experiment led him to a startling conclusion. The laws of physics must be the same in all non-accelerating systems. This idea, known as the principle of relativity, suggests that there is no absolute state of rest in the universe. Everything is in motion relative to something else. Now let's unpack this a little. Say you're seated on a train that's moving at a steady speed. You toss a ball up and down. To you, the ball appears to be moving in a straight line. But to someone standing on the platform, the ball's path seems curved as the train moves forward. The point here is that both perspectives are correct, depending on the observer's frame of reference. This is the essence of the principle of relativity. But there's a twist. Einstein took this principle and applied it to the speed of light. He proposed that the speed of light is the same for all observers, regardless of their state of motion or the source of light. This was a radical departure from the prevailing physics of the time, which held that the speed of light would change depending on the observer's motion. Einstein's thought experiment and his subsequent insights into the nature of light and relativity challenged the foundations of physics. It led him to question the very fabric of reality and to rethink our understanding of space and time. This realization was the first step in Einstein's journey towards the discovery of E=mc². But how did Einstein go from this thought experiment to the formula E=mc²? This question has intrigued numerous minds, and the answer lies in the fascinating journey of scientific discovery. Einstein's thought experiment was the catalyst that led him to a profound realization. He reasoned that if energy and mass were truly the same, they should be interchangeable. This concept was a radical departure from the long-standing belief in the conservation of mass and energy as separate entities. Rather, Einstein proposed that mass could be converted into energy and vice versa. The next piece of the puzzle was the speed of light, represented by the letter c in the equation. Einstein knew that the speed of light was a constant, a fixed value that never changes, regardless of the observer's perspective. This was a cornerstone of his theory of special relativity, which he had developed earlier. The speed of light is incredibly fast, so fast that it squares to a number so large it's almost unfathomable. So, if mass m could be converted into energy E and the speed of light c was a constant, then the relationship between them could be expressed as E=m times c squared, E=mc². It was a simple equation, but it represented a profound shift in our understanding of the universe. Einstein did not arrive at this conclusion overnight. It was the product of years of contemplation, calculation, and refinement. It required him to challenge established scientific principles and to view the universe through a new lens. But his tenacity and his willingness to question the status quo led to one of the most famous equations in the history of science. This equation, EMC2, encapsulates the idea that mass and energy are interchangeable, that one can be transformed into the other. It suggests that the energy contained within a single atom is immense, a concept that would later pave the way for the development of nuclear power and atomic weapons. And so, from a simple thought experiment, the formula E=mc2 was born. This equation, born out of Einstein's curiosity and intellect, forever changed the way we understand the world and our place within it. Now, we all know E=mc2 is Einstein's famous equation, but what does it really mean and why is it so important? Einstein's equation, E=mc2, is not just a mathematical expression, it's a key that unlocked a new understanding of our universe. It explains that energy, E, and mass, M, are interchangeable. They are different forms of the same thing. If mass is somehow transformed into energy, it does so according to the formula EMC2, where c is the speed of light, a constant. This equation, as simple as it may seem, has immense implications. It has guided the development of nuclear power, a form of energy production that harnesses the power within the atom itself. Nuclear power plants work by splitting atoms in a process called nuclear fission, releasing a tremendous amount of energy from a small amount of mass, as predicted by the equation. But this power doesn't come without its risks. The same principle that gives us nuclear energy also led to the creation of the most destructive weapons known to humanity: atomic bombs. These weapons work by initiating a chain reaction that splits atoms, releasing a massive amount of energy, again according to EMC2. Beyond the terrestrial, the equation also plays a vital role in cosmology, the study of the universe and its origins. It helps explain phenomena like the energy produced by stars, including our sun. Stars generate energy by fusing hydrogen atoms to create helium in a process called nuclear fusion. This process converts a small amount of mass into energy, lighting up the cosmos and making life on Earth possible. So the next time you switch on a light, remember that it's Einstein's revolutionary equation that makes it all possible. And when you look up at the stars, remember that it's E=mc2 that explains their brilliant glow. From the power plants that light up our cities to the stars that twinkle in the night sky, the impact of MC2 can be seen all around us. But beyond the formula, what is Einstein's true legacy? Albert Einstein, the man, the myth, the legend, his influence goes beyond the world of physics, reaching deep into the fabric of our daily lives. His theories, his ideas, and crucially, his imagination reshaped our understanding of the universe. No longer was the cosmos a static, unchanging entity. Einstein showed us a universe that is dynamic, ever-evolving, and mind-bogglingly vast. Einstein's theories of relativity, both special and general, have given rise to technologies we use daily. From GPS navigation to predicting the behavior of black holes, his work has had a profound impact. His legacy is not confined to his scientific achievements alone. His spirit of inquiry, the thirst for knowledge, the audacity to challenge established norms, these are things that inspire generations of scientists and thinkers even today. Einstein was a visionary, a maverick, a rebel. He dared to question, to explore, to imagine. His influence extends beyond science into philosophy, art, and culture. His name has become synonymous with genius, his face an icon of knowledge and wisdom. Einstein's legacy is one of curiosity, courage, and creativity. It's a legacy that encourages us to question, to wonder, to dream. It's a legacy that pushes the boundaries of our understanding and urges us to keep exploring the mysteries of the universe. Einstein once said, "Imagination is more important than knowledge."